Yes, okay, and we are recording. So we have the Q&A available, so at any time, feel free to post your question. For sure, if there is like a good time, I will answer to that. If not, then commonly I do that after the session. I do some sort of a Q&A appendix, and I do that with the video posting. So let's start. I hope I hope that this one will be interesting because 5G network slicing is really an interesting topic. So just a quick introduction about myself, if that's your first time to meet me. My name is Karim Rabia. I'm working mainly in the ICT. My core experience is in the mobile network, but along the last 16 years, I worked on the mobile core, on the IP network side, on the cloud, on the OSS, on the orchestration. So it's like my experience it's like spanned across multiple domains, and also I see the technology from different perspectives because I always tend to adopt a classical approach when it comes to technology. So I'm a contributor in many of the I'd say standardization bodies in the open source communities. So I always try to bring content that actually it's like a practical has a practical sense and also has some good reference from the standards. So what you will see here in the next slide is actually a mix of that. So I'm trying to assess network slicing from different angles, and whenever possible, I will always refer to the right reference or to the standards body. So just before I start, I will just launch a poll, like a quick survey. So please, if possible, feel free to participate. I hope you can see it now. You do, right? Okay. What I'm doing, why I'm doing that, because network slicing is actually I can call it like an end-to-end technology that spans across multiple domains, like right from the radio, from the transmission, from the core, even from OSS, BSS, cloud, orchestration. So it is important for me to understand the background, and also we will capitalize on that and build some sort of conclusion that actually this technology or the term itself, network slicing, has like multiple definitions in multiple contexts. So that's why, for example, in this slide, you see the title is a little bit maybe odd, but it's actually network slicing. Let me just finish the poll. Okay, thank you. So I see that the majority have like some SDN background, and also a good portion like from mobile fixed core, OSS, BSS, also a good portion from transport and radio access, and also from cloud and from IT. You see that we are all here from multiple backgrounds. So this is really a good start, because I know that the questions now will be actually richer and coming from different backgrounds. So let's start here and actually talk about network slicing. Network slicing is a very trending term, right? But we always hear it in different contexts. That's why I made this slide. I made this slide, and let me just activate the leader pointer. I made this slide to actually explain that network slicing comes in different contexts, okay? And it may maps to different meaning according to actually how it was positioned in the overall content. So if we start with one, we always have the content about explaining network slicing from business perspective, talking about the business case, talking about the opportunities, the expected revenues, and why we should go to network slicing. And you'll always see a content that actually focus on how you do the orchestration for 5G, how you do the automation for network slicing, okay? And then you commonly find content that actually takes network slicing to the containers domain and talking about the cloud native deployments and how can we do slicing from containers perspective. And it's always there, the content, the technical content that actually maps to 3GPP on how actually you realize network slicing from standard perspective, how you do slice selection, the thing that actually relates to the call flow and the overall understanding of the technology. And then finally, you can find the network slicing content or term maps to multiple other streams, right? Maybe some content related to edge. You find that slicing is positioned to talk about a use case in the edge. Sometimes you hear about the term SDN with network slicing. Sometimes you get, some content related to assurance, preventive maintenance, machine learning based, and always, private 5G is somehow linked to network slicing. So the conclusion here is that actually there are a lot of content talking about network slicing from different perspectives. In this session, I actually tailored the agenda based on these bricks. So I'll go from the business case and the opportunities, and then I'll take you on how and why we need an automation framework for slicing, and then actually the relation to the cloud, and then finally I will show you the code flow on a high level, how the slides being realized in a 5G system or a 5G architecture. So this will be the agenda for today. I will try to touch each topic on a high level, and let's call it like a starting point. And I hope in the next month and next weeks, we will have more in-depth sessions. So just a quick slide about how did we evolve to reach network slicing. So, and why most of the professional people working on the mobile and the mobility think that we had always a sense of slicing in our network. So starting from like, let's take a starting point about the 4G, for example, where I call it here a pre-3GP R13. R13, that's the release of 3GPP. It's R13. People working on mobility understand that. They know that R8 for us is 4G, R15 for us is 5G. So I'm talking about the era before release 13. Before release 13, we had this kind of architecture, high-level architecture. You had always the handsets, and you had the EO-TRAN, which is the radio part of the 4G, and you had the core network, which is the evolved packet core, the EPC. And then you had the concept of having dedicated APNs for dedicated segments, right? You always had like an APN for consumers, APN for MMS, and APN for B2B or for corporate. So in that architecture, we had a sense of slicing by dedicating APNs to customers, in the radio by having some sort of bearers. We called it bearers. There are some two types of bearers. People know that working on the radio, like default and dedicated. But anyway, at that era on the 4G, we had a sense of slicing, a logical slicing using APNs, using bearers. Maybe people of transport say, okay, using VRFs. So we had a sense of slicing, but not a real slicing, because at the all, we were all sharing the same network. So we had an evolutionary step in R13 and R14, where in the 4G, the standards introduced the concept of DCN, or dedicated core network, or commonly called D-core. So in D-core, the 3GP introduced a framework that can have a dedicated core network, or splitting or dividing the core network into DCNs that can be allocated to different customers. So for us, that was the kickoff or the starting point, or setting the stage for a real 5G slicing. It started in 4G, but there was no real adoption by that time, because people were all waiting for the 5G, waiting for the slicing. But the point here that it existed in the 4G, in R13 and R14. And then we reach the complete slicing framework, starting from R15, 3GP R15, which was actually the 5G network slicing. As you see on high level, with 5G, you are able now to get what we call NSI, like network slice instance, that you logically segregate or divide your network. And when I say network, this means the access. You see the 5G access network and the core and the transport into slices, network slice instances. And then the standard suggested a term called SST, slice service type, that for each slice, it will have like a unique SST. So if you are like, for example, an evolved or enhanced mobile broadband, you get an SST of 1. But if, for example, you are a V2X or a V2V in the V2V industry or V2X industry, then you get an SST4. So I'm just here like giving a high level of the evolution And the conclusion is that we had a sort of slicing before 5G under different names, under different technologies, but they were not that mature and were not highly adapted. And then when we go to 5G, that was actually the starting point to have a real 5G network slicing. So if you ask me from a standards perspective, from 3GP perspective, did you have the term network slicing before 5G? The answer simply was no. But we had similar technologies that was actually setting the stage for 5G network slicing. I see some questions. Let me just have a look. The DCN is VPC. The DCN is a dedicated core network. By that time, it was not implicitly or explicitly referring to a virtual EPC, because 3GP was not concerned about being virtual or physical, but it's a concept. You realize that by physical or by virtual, it was up to you. So it's not a virtual EPC, but it was realized by virtual EPC. So let's take it now in a logical way, okay? Because that's the right way to understand slicing, is actually to understand the business case. Why should we go for slicing? Why operators are keen to explore slicing? And then we see the underlying technology. So I actually, because I'm working on the OSS and the orchestration, so I'm kind of attached to TMF or TM Forum, which is actually doing a lot of work and effort in the OSS BSS layer. So let us just explore the infographic, that the one on the left, because it has very interesting information. So what is actually tricky about the mobile broadband in general, and the offering data packages to the customers, that actually whenever you do an upgrade for the technology, you cannot charge them for a premium. And for example, if you are giving a data package, for example, for 2 gig to a customer, and then you are offering him a 4G coverage, then he will pay X. Then if you do the evolution and then you go to 5G and you still give him the same package, most probably he will not pay other than X, right? Because he's taking the same data. He doesn't care actually about if you are doing that through 5G or 4G or Wi-Fi. And that's one of the pain points at the CSP side, at the operator side, that you enable technology, you invest a lot, but at the end you cannot charge a premium to the consumers. And that's actually the case of the 5G. Okay, charging a premium for 5G consumer is not commonly feasible. Okay, so getting more money from consumers will be really a hard track. That's why that survey that was conducted by TM Forum, 71%, 71.5%, okay, they believe that the CSP revenue will come from B2B, right? So B2B, or the enterprise business unit, that will be the most important part, the department, right? Because that's where the revenues will come from 5G. But what is the challenge here? The challenge here actually is in the right infographic. If you see the right infographic in a nutshell, and that's a survey by Capgemini, okay, it showed that 1/3 of the executives or the managers or the leaders of the enterprises are thinking to have their own 5G license. So that's a threat, right? So if the enterprise itself is looking to have their own license, so what will be left for the CSPs? So I'm a CSP, I'm expecting all the revenue to coming for the B2B, but I'm watching the B2B market is moving slowly to acquire the license, right? That's why the conclusion, and again, I like this TMF publication, that's the 5G, okay? Either the enterprises will come or new players will come and they will cut the operators from the equation, okay? They get their license, they get their end-to-end 5G solution, or mobile operators still keep like a feet or a slot in the game by network slicing. So actually, either as a CSP, I build a network slicing end-to-end solution of automation and orchestration and offer that to enterprises, or there will be new players, even the enterprises themselves, they will start to capture the opportunity. Just one quick question. Okay, so this is the case. This is about the opportunity and why there is a focus on the enterprise market. So slicing is very coupled with the enterprise strategy. So it's 100%. I would say 99% solution tailored for enterprises. And what is the market potential? Some infographic from GSMA. If you see that, like for example, from expected revenue, so there is a revenue opportunity of 300 billion US dollar by 2025 as per GSMA. That's a huge money to catch, right? And if you recall the last slide, there is a threat, there is a challenge. That's why CSPs are really keen to have a framework ready to streamline and to streamline and automate network slicing for enterprises. And as you see here, the from 2020 to 2026, there is like a CAGR, which is compound annual growth rate. So there is a growth rate 20.8% of the forecast or of the value of network slicing. So there is a very good market potential. There is a very good focus, yet there is also a challenge for CSPs. What is a challenge, if you ask me? And I think from the survey, I see that we are all coming from technical background. The challenge, actually, the real challenge is the business case. Business case is still a threat. As I told you in the beginning, I always try to bring a reference from what I'm saying. So I searched the internet. I found a very good survey done by Mobile World Drive under GSMA in March last year. So the challenge or the threat to adopting the 5G in general or the network slicing is the lack of business case. And that's a very key point, okay? And that's also an advice to all the colleagues working on the technical field or technical domain. Doing investments, huge investments without a business case is like committing a suicide. Why? Because actually it's not like the old days, right? You invest in 2 cabinets or 3 cabinets, building a core. Network slicing can be a huge number of slices. So you need to do a huge investment in terms of infrastructure, in terms of automation and orchestration, in terms of everything. It's an end-to-end ecosystem. Same like the edge, for example. You cannot go and like build thousands and hundreds of edge pops without a business case. So the advice is always build the business case, communicate with the EBU, make sure that you have like a clear pipeline of customers before you do the investment. Okay, but how actually you're going to sell these slices to enterprises and how you are going to charge these slices to enterprises? And that actually will be the point that will take us to the automation and orchestration. So slices like have some sort of characteristics, right? And these characteristics in a way or another will be somehow modeled on how you build the slice. So the characteristics are all coming from the enterprise requirements. So for example, if you are talking to different verticals, you are talking to mining, to agriculture, to health, to V2X, vehicle to everything or anything, BMW, Audi. So every vertical or every business entity have its own requirements. I have here 3 categories. For example, we can just quickly scan them. Like in terms of performance, maybe a certain customer will ask you for an ultra latency slice with a certain latency, like 1 millisecond, 2 millisecond, with a huge throughput. Okay, so that's a requirement. Maybe a functional requirement in terms of mobility. For example, like I want my employees to be able to do a mobility between this slice and overall the big network from the CSP, or between 2 slices. And from operational, me as an enterprise customer, I want to have the full visibility on my slice. I want to have to enable AI-based preventive maintenance. I need to have a strict SLAs. So all these parameters shape actually how the CSPs are going to craft their commercial product. Okay, because the charging in slice, and that's a very interesting thing. People working on the mobile, they know that commonly charging is actually done by volume based or time based, right? So you calculate the consumption in terms of gigabits or whatever, and you charge, or you give like time based charging, like you give service for a certain time. But here, most probably, the charging will be based on SLAs, based on these requirements. So if CSP violate the SLA, he will not get the money from the enterprise. So from that perspective, it's time now like to give a definition for slicing, right? And we can say that 5G slicing is actually a segmentation of the 5G network into virtual network, each virtual network optimized and modeled for a certain business case, like agriculture, mining, V2X. That's according on how the CSP approach the enterprise market. I hope this is clear because from that slide, you can easily identify that there is a need for a framework to model slices to govern the life cycle management of slices, for example, to have slices ready to be instantiated, scaled, healed, terminated, and exposing that in some sort of a marketplace or a digital channel to be sold to enterprise customer, the same way, for example, Amazon or Microsoft or Google do that for their customers. I have like quick questions. I'll just take two questions quickly. Is it easy for enterprise to get a license and build 5G core? So in some countries, yes, we are seeing that in Australia, in Germany, maybe in the Middle East, it's not like that, but it is coming. It is coming. So let me close that one. So we understood that, okay, when there's a business case and you're talking to multiple verticals, so there are multiple requirements. So you need to craft different products for different verticals. And these products are actually triggered or requested on demand. For example, you have to offer a framework for enterprise customer to come to your portal, click, I need a slice, and then in a zero-touch provisioning way, in a no time, he gets a slice provisioned, and then at any time he can go and say, okay, I don't want it, and then you do a charging per SLA. So it's a very dynamic framework. Okay, you cannot do that in the old way by having customer representatives taking orders and putting orders, and then you send emails. No, no, no. They have to mimic the same experience they get from public clouds, for example. The same way you can get a service from Amazon, it's actually the same way the enterprise customer should get it from an operator. So you need a framework to govern these four things. So if I'm using now the laser, so you need a framework to do slice modeling. You need to have templates ready to address the verticals requirements. For example, if you are doing a slice for the mining and you are deploying the slice at their premises and they have like very critical requirements of latency, then you have to model a slice that fits this requirements. And you can do the same for other verticals. Creation, operation, termination. You need to have a framework that actually do an on-demand instantiation, whatever the enterprise customer require that. And then whatever the slice in service, you need to do monitoring, continuously monitoring. You need to do scaling, healing, all the lifecycle management procedures that commonly achieved. You need to do that and actually expose that to the enterprise customer, so he can see exactly what's happening on my slice. And then at the end, you need like the same framework to handle the decommissioning or the termination. So it's a full life cycle governance by this new framework. And that's why, to the first time, with the 5G and with 3GPP, first time for 3GPP to talk about an orchestration framework. So it's not only talking about how to realize network slicing, but it also brought a framework for orchestration. And here I'm showing the new concepts that came with the 3GPP. Maybe people working on orchestration and automation, they know that this is not something new, but for 3GPP and for the technology tribe, that was actually something new. So what are these new concepts? So 3GPP came with the term communication service. Communication service, or we can call it CSI or a CS, that's actually the service that is being provided to the external customer. Or we can call it in some terms the customer facing service. This is the service that you are giving to the external customer. For example, let's name it for clarification, like gold slice. I'm an operator, I'm selling a gold slice. Okay, this gold slice, in the underhood, it maps to an NSI, which is network slice instance. So each service you sell to the external customers maps in reality as a resource facing service to a network slice instance. Okay, these network slice instance, and as per the standards, it actually spans across 3 domains. And that's the definition of network slice in 3GPP. And that's the slice in the standardization definition. So there are NSSI, which is network slice subnet. So network slice instance consists of different network slice subnets. And each network slice subnet, it lives in a certain domain. And these domains by standard are the access and the core and the transport. So access, which is the radio or whatever access type, transport, which is the MPLS, transmission, whatever, and the core network. So these are the 3 domains that each one of them host a slice subnet. 3 of them, they construct a network slice instance. 3GPP commonly is focusing on the core and access. Transport maybe by other entities, ITF maybe, but the focus of the 3GPP is on the core or on the access. So this kind of concepts were introduced by 3GPP, but people working on the orchestration, they know that this kind of thing of service decomposition, it has always existed in the in the orchestration concepts that exist, for example, in TMF, for example. So with slices, okay, and you will see that the number of slices can actually go exponentially high, right? Because from a standards perspective, you can go to 2 to the power 32 slices leased by the network. Any CSP theoretically can lease and dynamically govern 2 to the power 32 slices. So you can have a lot of slices, right? Slice for EMBB, slice for machine type communication, certain slice for enterprise, certain slice for MVNO, and you can have n slices with n offerings, right? So there is a must to have an orchestration framework. Now we realize why there's a need for orchestration framework, because you will never be able to scale and to efficiently work on the lifecycle management of these slices, on these dynamic slices, without an orchestration framework. And for that, there are new functional blocks came with 3GPP to define the function or that you need to govern the slicing. So they came with CSMF, NSMF, NSSMF, and NFMF. CSMF, communication service management function, that's doing the customer facing part. Okay, the lifecycle management of the customer facing part. You remember the communication service that we explained last slide. This is what the functional block that handles the lifecycle management of the customer facing services. NSMF, network slice management function, from the name, that's the functional block that does or that handles the lifecycle management of the network slices that spans across multiple domain. NSSMF, from the name itself, network slice subnet management function, that's the node that is doing the lifecycle management of the network slice subnet, which runs either in the core or access or transport. And finally, we have the NFMF, NF management function, very, very similar to the EMS capability that used to do the FCAPs for the VNFs or PNFs. So these are the new functional blocks. What is interesting will come in the next 2 slides on actually how the vendors mapped these functional blocks into their existing solutions. Because most of the vendors, they had a framework for orchestration, right? And they saw these new things from 3GPP. So then what was interesting is how actually to position these nodes or these functional blocks into the existing solutions. So I will take a question and then I will talk about this one. Okay, the question is, my understanding is that things like NSDs, CNFDs, VNFDs will map to NSSIs. So that's an interesting question, because I'm going to answer that in this slide. So it's actually a good coincidence. So I will answer it now. So the question is actually, this NSSI, network slice subnet instance, does it map to network service descriptors on the NFV domain or the CNFDs or any kind of descriptors in NFV? Actually, when these blocks were placed in the standards by 3GPP, they had to put some sort of a framework on how these blocks integrate to the existing brownfield cloud deployment. So there is a very interesting, diagram which I'm showing here. It's actually an attempt from 3GPP to show the community on how these nodes integrate to the existing, for example, HCNFV stack. So as you see here, the NSSMF, the one that is handling, let me just, the NSSMF, the one that is handling the lifecycle management of the slice subnet into a specific domain, it integrates with the NFVO. It integrates with the NFVO. So that's an implicit answer for the question that whatever network slice subnet instance here, it maps actually to a network service defined at the NFVO. Yani, for example, if the slice subnet in the core is an SMF and UPF, then you will find a corresponding modeling for a network service in the NFVO that maps to SMF and UPF. So it's some sort of one-to-one, and sometimes it's actually maybe one to N in terms of VNFs. So the architecture was suggesting that NSMF, because it's managing the slice in multiple domains, so it integrates to NSSMF in the core in the radio, and it integrates with transport as well. The NSSMF as a we can call it a domain orchestrator. It can act as a northbound system to the NFVO, and then the NFMF, which is, as I said, as an EMS, it continues doing the normal functions, integrating with the VNF and the PNF. So it was just a logical representation. But what is there in reality and the big picture, and that's something that really interesting, is actually how these nodes maps to the vendor solution and to the overall architecture. So what you see here, that actually CSMF, from definition, it actually gets the service order from let's say from the BSS, from digital channels, from actually something facing the customer. So the CSMF, NSMF, what you see here on the right is actually where it maps in most of the vendor solution. So you find many vendors coming with the terms multi-domain orchestration, slicing manager, end-to-end service orchestration. Most probably the new logic of CSMF, NSMF is embedded into these three terms, either multi-domain orchestration, slicing manager, end-to-end service orchestration. However, some vendors who have good presence and good existence in IT systems and in BSS, they can go and put the CSMF into the northbound layer in the service order management, or in the order management umbrella in layer in general. So the CSMF, NSMF is commonly positioned in any multi-domain orchestration or end-to-end service orchestration layer that any vendor provide or any CSP build. But what about the NSSMF? The NSSMF, which is slice subnet, and as per the standard, it's core and transport and access, most probably this solution is positioned in a domain orchestration solution by the vendor. So any vendor providing a domain orchestration for the core, for the transport, for the access, for whatever, most probably he will position the NSSMF in this one. And the NFMF, because it's not here, is commonly part of the EMS. And some vendors are gathering NSSMF and NFMF in one solution. So it's very interesting to see how this is positioned. I know that in your job, in your work, you will meet these solutions, but from a standards perspective, CSMF, NSMF is a northbound system that control integration with the customer-facing systems, and integration southbound to the multiple domains where the slice lives. And NSSMF, that handles the lifecycle management of the slice subnet in a specific domain. Down here, you see there is a layer called the cloud orchestration, right? And it's a little bit generic because it includes NFV orchestration and container management orchestration. And why I did that, because that's the reality. There is really an uncertainty about this layer. And that's actually the starting point for the next slide, because I'm going to show you what do we have in the container domain. I mean, does the slice need, or is it mandatory to live on containers? Yes or no? Do we need an NFVO in the picture? Yes or no? But at the end, we need a layer to do the cloud orchestration. Either it's NFVO, either it's directly like Kubernetes-based solution or whatever there in the market, but we need a solution to do the slicing from cloud perspective, from resources perspective. Let me stop here and just get one question, and then I'll be back. Okay, the question is, during NSI instantiation and NSN service phase stage, where does NSF come into picture? In other words, when and how NSF talk to NSMF, NSF? That's a good question. Let me reply to that live. So how the integration should go. What I'm going to do now is a very informative high-level flow just mapped on this architecture, okay? So what happens in reality, again, it's a very high level, but it is. So whenever an enterprise customer come to the marketplace and put an order to purchase a certain product, which is network slice, for example, offering, this customer order triggers a lot of processes, right? Charging, CRM, whatever there in the BSS. And at the end, a service order will come to CSMF that an enterprise customer or there's a request to instantiate a slice. And based on the modeling done on the CSMF, based on what is defined on the service catalog on the CSMF, NSM, the command or the API is conveyed to NSMF, and NSMF do a service decomposition and say, okay, for this slice, because that's a gold slice, I will have to communicate with the NSMF in the access and the NSMF in the core, because this offering is actually built on a for example, a RAN node, which is, for example, a CU user plane and a UPF in the core. Okay, and then this NSMF will get the request and communicate with the cloud to instantiate the CNFs or the VNFs and have the network stitching between them. So either this request goes to the NFVO, like in the HCNFV world, or it can go directly to a containers management layer that actually can integrate directly to NSMF. So that was a very high level, and there are a lot of details. I hope we will have time in next weeks to actually focus on this point, because a lot of details on this one. So that takes us to the containers, right? What's happening on the container world? And I'm just trying to go that quickly. So now in the telecom domain, we have 3 tracks, right? The monolithic telco VNFs, like the light VNFs that used to be there, like AAA firewalls, web servers, are already containerized. Second track is that CSPs acknowledge now that containers became a prerequisite for 5G core and Open RAN already on track. So the cloud is evolving from infrastructure as a service, VM based, to providing container as a service and platform as a service, while the legacy telco VNFs, the giant VNFs, will still remain as it is, either PNF or VNF. There is no real momentum for containerization like HLR, MSC, and that thing. So what's happening now in the CSP's mind when it comes to cloud? There are some facts, and they have to live with it. What are these facts? Most of the 5G core, or actually the 5G core all, is based on CNFs, so they have to be ready to host this 5G core. And the radio, CU and DU, is on track. CU is there, DU is coming, or vice versa, but it is coming. They all acknowledge that they have to have a framework for CNF lifecycle management to support the dynamicity of the service. Service is on demand, lease, terminate, scale, heal. So they have to have this kind of layer on the cloud level. This cloud deployment or cloud governance will extend to the edge, because most of the slicing use cases, enterprise use cases, are going to the edge, either you name it telco edge or enterprise edge. However, the same strict requirement that we had in the core, 5G, 4G core, will still be there in the 5G core, and will be actually more strict when it comes to enterprise. But there are some doubts, okay? This is a point that actually, there are a lot of directions. There are now existing on-prem clouds in the CSPs, right? Private clouds like IT, telco. So do we invest on these clouds, or we like having a brand new cloud? How can we solve this multi-cloud orchestration or multi-cloud governance? What will be the role of the existing NFVO or existing HCNFV? Will it scale to handle the containers and have a role in the 5G cloud or cloud native deployments? And then on 3, there are a lot of new players, right? Offering 5G core, offering orchestration, offering containerization. So shall we deal with these new players, or we stick with our telco giants, the big names? We as a CSPs, we used to provide, I'm just speaking as if I'm a CSP. So we are providing infrastructure as a service, right? Like VM based, virtualization. How to evolve? Because we need to manage container in bare metal, and container maybe on hypervisors. Maybe we can go for a pass, right? Because 5G core may need platform as a service. And can we evolve to anything as a service? So how to evolve, how to take the step forward. And then lastly, the hyperscalers, the cooperation with hyperscalers. It is there on every, in everywhere, cooperation between CSPs and hyperscale, like how to cooperate, whether to cooperate, yes or no. These are the doubts that the CSPs are having. And as you see, the CSP's cloud, it has to evolve from an infrastructure as a service, hypervisor or VM based, to container as a service, platform as a service, and anything as a service. I have 15 minutes, and I have a very, I would say, interesting part. Let me just remind you of the storyboard. We had a highlight about the business opportunities, okay, and then from that we realized the need of having an automation and orchestration framework for 5G network slicing, and then we reached a layer that we have to integrate with, and we have to live with, and we have actually to bring it up, which is the cloud orchestration, and that took us to the containerization and cloud native deployments, and what are the doubts that the CSP is having. But from technical realization, and that's the part maybe people working on the mobile core and the mobility in general, they care about this part, how actually to realize network slicing. So you were able to instantiate a slice, but how to select this slice to the particular customer. So that's the 5G service-based architecture. I'll not re-explain that. I'm sure you showed that before. But what is interesting here is that the service-based interfaces, most of the control plane or all the control plane of the 5G now, the interfaces are based on APIs, right? It's not like the old days based on diameter, SIG-TRAN, and these kind of things. So let's take it one by one and see actually how slicing is being realized technically. I brought a high-level animated diagram. I hope you find it useful. For sure, there are a lot of other information in the standard, but I just extracted this slicing logic. Before I start, let me just get one question, and then we can start. Okay, that was a thank you. You're welcome. Let me. Okay, so please, guys, just refocus now, because that's a really interesting part. So slicing can be anything. For example, you can dedicate an EMF. You can share EMF with certain enterprise. You can dedicate SMF, UPF, only UPF, AMF, SMF, UPF. There are a lot of multiple combination. It can even reach a full private 5G with all nodes dedicated to a certain enterprise. Let's say for this flow, we are going to dedicate or select a certain AMF, SMF, UPF, and a part of the radio, and I'll explain that, to a certain subscriber. So what happens in reality during registration, and that's similar to the attach, for example, in the 4G, the UE sends what we call a requested NSSAI. The NSSAI, it's actually the network slice selection assistance information, and from the name, network slice selection assistance information. That's what assists the network to assign the right slice for this UE. UE, the user equipment. And the term requested, when you say the term requested, it always comes from a UE. People working on the mobile know the term requested is means it's coming from the UE. So the UE sends, say, guys, I'm requesting myself to be in a certain slice, and I'm showing here the NSSI structure. So it includes the SST, slice service type, and slice description. So that actually some 32 bits that describe which slice that I belong to. The request goes to the G-Node B or the 5G RAN. So this information, the NSSI, can be used as a factor in RAN selection to which AMF, okay, to which AMF should this UE be served. So let's say that, okay, that the RAN were able to convey the message to the AMF, okay, and now the AMF got the registration request from the UE. Third thing it does, it go to the UDM, similar to HSS in 4G, and ask the UDM for, please tell me what is the subscribed NSSI for this UE. So this UE is allowed to use which slices, okay? For example, if I want to slice 5, but the only allowed subscribed for me is 3 and 4, then my request will be rejected, okay? So I check from the UDM, AMF checks from the UDM, which NSSIs are subscribed for this AMF. Next up, for some reasons, if the AMF itself cannot serve this slice, or for example, the UE requested a certain slice like 5, and the AMF is not the one serving this slice, so it can consult the NSSF, network slice selection function, that please tell me which AMF should serve this UE. But if I am the one who is serving this UE, then I will not go and consult the NSF. So at that stage, at least for that stage, we know now which AMF, okay, serve this UE. Either I am the AMF serving the UE, and because of the NSI that I'm serving, or I consulted the NSF to get the exact AMF that I'm going to send the UE. And then the last thing, that I go to the PCF, like the PCRF, and then I get something called network slice selection policy. What is network slice selection policy? That's a very nice term. Me as a UE, I can have multiple slices. I can have multiple slices, can go to 8, for example. So which application or which traffic goes to which slice? And for example, if I am a UE, I'm doing a voice, and I'm doing a video, and I'm doing a normal traffic. Maybe video can go to slice 2 and traffic can go to slice 5. So what governs that is actually the network slice selection policy by PCF. It instructs the AMF to which uplink, to which slice, which traffic should go. Okay. So at that stage on the registration, I finish the call flow by being able to dedicate this AMF for the UE. Now we know that UE in slice 5 is served by this AMF. So what is left? What is left is actually when the UE is trying to establish a session, a PDU, to assign the right SMF and UPF to this UE. And that happens in the PDU session establishment. That's a post process after registration. UE send a PDU session establishment request. As a UE, I want to do a session, and that goes to the AMF. Now the AMF, it is in doubt because it wants to select the right SMF for this UE, the SMF that exists on the slice assigned for this UE. So it goes again to NSF and ask NSF, please, I need to select the SMF. So NSF, as you see, it replies with NRF for service selection. NRF, in a very simple definition, maybe it's not a really right one, but I can use it. NRF, you can consider it as a DNS. So NSF instructed the AMF, please go to NRF with the slice indication. And then NRF will give you the right SMF to serve this customer. And that happens after consulting the NRF. So AMF can easily now select the SMF, and then SMF, with the same logic, it goes to NRF, and as per the standard, with the slice ID or the NSSI, it can select the UPF. So UPF now is selected. So you see that AMF, SMF, UPF selection can be based on the slicing information. So there is a framework in the standards to select the slice for the UE, either it's AMF, SMF, UPF, based on slice information. Is this the last thing? No, there is a very detailed point that when I say RAN, for example, RAN in 5G, that's the G node B, but the G node B in reality, it consists of a CU and DU, right? Central unit and distributed unit. And the CU, there can be multiple CU user plane. So in reality, there are multiple CU user plane can serve or can exist in one G node B. So what happens in reality, or as the end of this call flow, when the UPF send like some sort of positive outcome to SMF, to AMF, in the process to AMF, in the message called initial context setup request, in this message, there is a slice information. There is a slice information. So even the RAN can do a user plane selection of the CPUP based on slice. This means theoretically, you can have a slice that consists of CPU user plane of the RAN, AMF, SMF, and UPF. That was just a high-level animated diagram on how you can select a slice for a UE. I hope it was clear. Let me just have a look on the questions, and then we can conclude. We have 5 minutes. So I have a question. Yes, and NSF interrogation can be skipped. Yes, yes, exactly. But this may be valid where we have separate NRF per slice. Uh, well, you can have separate NRF per slice, but this is not the common approach. I would say this is not the way vendors are thinking. NRF will always be centralized, belong to CSP, not belong to slice. If a user uses F having all these traces configured, okay. So the question here is if a UE requests 3 slices and there is no common AMF having these 3 slices configured, so in that case, will the UE request will be rejected, or it is compulsory to have at least such a common MF which could cater to any combination of slices for NUE? Okay, that's a good question, but it's a little bit tricky, yani complicated case, because accepting or rejecting the request comes from many factors. Like there is subscribed, right? Subscribed NSI coming from UDM, and there's the concept of allowed and configured, and there is allowed is actually the intersection of the allowed showing the capability of the network. So there are a lot of combinations. I prefer to have it somehow written, because it's actually have a lot of logics based on the UDM input, based on NSF input, and based on the AMF capability. Okay, so let just defer this question. I mean, I'll try to draw it in a slide, and I can maybe send it. It's a very nice question. I can send it as part of the slides. Uh, yes, exactly. Thanks, Shabu. What? Okay, there is a question. What would be the benefit of slicing of the RAN? Okay, that's a very good question. Let's just acknowledge now, because we have 2 minutes, that the framework of slicing in the core is more mature than the one in the radio. Okay, and the business case hits most probably the slicing in the core. The slicing in the radio is a little bit vague from business case perspective. Why would a customer get a user plane, CPU user plane for slicing? What is the real benefit? So I can see, for example, if you are doing an edge use case for enterprise, then you have to have a local breakout mechanism. So all the gateways, all the user plane components must coexist in one place. So it is really nice if you can give him or dedicate him a CPU user plane on the edge, because if you're not doing that, he will have to go and get the user plane from whatever the radio is, and then come back to the edge and get the UPF, for example, local breakout. So I worked on some edge use cases, and that was the requirements to have the CPU user plane in the enterprise premises, and that was the way to do that. So maybe it makes sense, but I agree that the business case for radio slicing is not yet clear, similar to the one in the core. Okay, how will NFVO decide which HDC is nearest to the UE? That's a very good question, because slice positioning is a very critical subject, right? You can essentially slice, but where to put the slice? So the common approach here is actually to work with metadata, like in the APIs from the NSS MF to the NFVO, which is to instantiate the network service or network slice, is to have some sort of metadata that can influence the decision on the NFVO to do the placement. So that's the direction now. But I would say it's not covered by any standard, but that's a very good question, that there should be something in the API to the NFVO giving him some instructions in terms of metadata on where to position the network service. Uh, okay, I think we're almost, yeah, it's 12 here, so it's 1 hour. I will have to, I would say, yeah, because I don't want to take more than 1 hour. I will take all the questions, and I will do like a frequently asked questions, or maybe like Q&A, and I will also upload that with the slides. I hope it was I would say a good one. I hope you found it interesting, and I hope it gave like some overview about different aspects from network splicing. If you have any comments, if you have something to say, I think we can stay for 1 minute. If not, then I really thank you for being here, and hopefully we can have that on monthly basis, or even more frequently. Uh, Ashtush, you are saying that NSF does not interact with CSMF and NSMF. Yes, exactly. NSSF does not interact with CSMF and NSMF. The terms are very close to each other, right? So yeah, exactly. So yeah, yani just it's NSSF, and there is the NSSMF, and there are many terms in the same thing. But what you're saying is completely right. Thank you all again, and hope to see you again. Thank you.